Okay, my microphone is here. Fine, excellent. Now how can I change it? Now it seems to be working here. Okay, very good. Thank you very much. All right, so the introduction, I will try to, first of all, let me tell you that my presentation is a continuation of an excellent presentation of my predecessor, Stephen Chu, and I will cover those subjects which he has not really covered in such a vast project, so I will try to be complementary to what he has said. Now, the availability of an adequate primary energy is one of the essential needs for the future of mankind. Renewable energy are advancing, but no doubt, sorry, that's the thing will work like that. Okay, I'm getting there. It doesn't move again. It's not moving. It's not moving. Excuse me, can somebody tell me what's happening here? No, it's not moving.
It's during introduction.
But it's not writing anything. I'm sorry, I don't know how to do it, okay? Now it's going, okay, fantastic. Renewable energies are advancing, but no doubt, fossils will continue to be massively used in the many decades to come. Energy is directly related to the evolution of the Earth's climate, unsuspected catastrophic events, and growth in population. As a premise to the future of energy, I will initiate with a brief description of these events in the past and how they are likely to develop in the future. The beginning of life earliest undisputed evidence for life are the methane and fed fossils, like stromatolites found through 3.48 gigayears old sandstones. Exposed materials are the oxidized between 2.5 and 2.3 gigayears. Oxygen began to accumulate with the extinction of most of the planet anaerobies and their progressive mutation to aerobies. The source of the organic oxygen in the atmosphere has been tiny cyanobacteria producing photosynthesis during gigayears. Life remained energetically limited until widespread availability of oxygen, which was proceeded in several stages, as indicated in this graph. Okay, now. The planet as a snowball is my next point. But although the temperature of the sun kept rising, the Earth and the planet did not get warmer. They get cooled dramatically. Glacial deposit in South Africa dated 2.4 gigayears and then located in the equator show the Earth is totally frozen. Since such a glass age around 2.3 gigayears could have been directly caused by the incoming oxygen concentration in the atmosphere, which caused a decrease in the atmospheric methane. There were 4 periods, which each lasting about 10 million years, between 750 and 580 million years, with the Earth thought to be covered with ice at average temperature of minus 50 degrees. The process should have finally been reversed in a known way, maybe by emission of carbon dioxide for the volcanoes or this stabilization of methane gas hydrate. The evolution of the climate, the evolution of global temperature in the last 500 million years is corresponding to the origin of multicellular life has been characterized by a series of cycles between glaciation and warmer periods. There have been about 4 of such a gold-like cycles separated by about 140 million years. The Neoproterozoic era, between 1 billion and 541 million years ago, shows important glaciation with freezing up to the equator. The global Earth temperatures of the subsequent 600 million years are described as alternating very warm temperature and glaciation. As you can see here, the initial temperatures are now it's stuck again. Okay, no, it's not working again. Yes, fine. So you can see that essentially very warm temperatures followed by the system. The important last period are the last million years, where you have melancholy cycles developing in the remarkable new state in the last 20,000 years of a remarkable today's stability. The climate in the last million years, in fact, is represented in this graph here. You can see that it's been characterized by glacial, interglacial period of gradually deepening ice ages. This glaciation involved fluctuation driven by changes in the Earth orbit, as done in Milankovitch cycles. The billion years ago, there was been an unexplained switch from the periodicity for 41 kilo years to 100 kilo years. Currently, since 10,000 years, Earth is in an extremely stable interglacial period of unique solutions. And this is shown in the next picture, which I think is worth looking at. You can see here the picture. You can see that, in fact, the global average temperature during time has been essentially dominated by glaciations, with very few periods in red, where indeed the possibility of a climate situation similar to today's are there. Now, that raises the important question of the future, and in particular the question of whether a future glaciation is evitable or inevitable in the future. The present warm period would normally be expected to last for no more than few more kilo years. The Milankovitch theory predicts the glacial period, periodically covering the higher altitude of the continents, will occur cyclically because of astronomical factors, combination of climate feedback mechanism. However, the increased rate of carbon dioxide released and other actions from the main may delay the onset of the glacial periods by a certain period of time. Our global warming induced through a few centuries worth of greenhouse emissions may only have, however, a relatively local impact. A future but inevitable forthcoming glaciation could be dramatic to the survival of billions of people. Sorry, let me get the next page. A main event other main event in the Earth's history is the mass extinctions. You can see them here. A number of mass extinctions. There have been 5 big mass extinctions in the last 500 million years. And the 6th extinction is, of course, the present one, due to human activity. And about 30% of species are at risk. Unexpected catastrophic events are also extremely important. Here's, for instance, in an eruption which will occur near Italy, in 40,000 years ago, in which ash layer of about 1/2 meter or more cover over more than 300 kilometers cubed. Now, coming to the people's question is an important question. The people population's growth rate at every second, 21 people are born and 16 die. A net gain of 3 people per second. Every day the population increases by 200,000 people. The growth rate has been incessantly rising and is currently approaching 90 million per year, with a rapid blow-up of population expansion, like a novel today's Italy every 9 months. Such an immense increase of the human species is one of the most extraordinary revolutions of our planet, and no doubt the condition in the future of the man. The total number of individuals which have ever lived on Earth is estimated to be 150 billion. Because of the exponential growth, as many as 5 to 10% of all human beings which have ever populated Earth are alive today. The growth of the energy demands is, of course, an important question which will be discussed. The beginning of the year 1800, population 1 billion. The average power was about 1 kilowatt per person, about half of the horsepower, 10 times the human strength. Since 1850, energy has grown as a square of the populations. During the last 80 years, which is my population, the global population has grown by a factor of 3.4, and the energy production by a factor almost 12 times. By 2050, we shall be reaching the 10 billion people mark. The year 2000, mankind consumed 14 terawatts per year. For the US, this number is 14 tons per year per person. There is, of course, a reference case to this effect, which is coming from the year. Here has shown that the renewable have contributed only in a very modest factor to the development of the energy. In the next 30 years, most expectation predicts 9 billion people and a growth with a factor 2 increment both in natural gas and renewable, and the steady consumption of coal and nuclear. And that, of course, requires the situation of the coal behavior in the past. In the coal behavior in the past, the concentration was very many times greater, although the exact value may be in doubt. 600 million years ago, the atmospheric CO2 was about 20 times larger than today. It dropped and then raised again, and the burning, the fossil fuel is leading cause of incremental CO2 now at 400 ppm volume. In 2010, for 914 carbon of fossils were increased compared to 6.1 in 1990. Therefore, future natural gas is an important alternative for the future, and here there are three possible alternatives shown in this graph here. In one alternative is a conventional process with CO2 emitted in the atmosphere. The second alternative is geoengineering attempts to compensate for the CO2 emissions. A novel method of natural gas from fossils, which I will discuss later, is fossils without CO2 emissions. The new forces of events type of novel natural gas the technologies are indicated here, they're well known, are essentially shales called methane. It is also important to recall the existence of clathrates, which is the largest untapped fossil natural gas reserve. For this oil, we have 200 gigaton carbon. Coal is 5,000 gigaton carbon, but clathrates are 12,000 gigaton carbon available essentially in the seas. And here is shown how the location where clathrates are observed. You can see that essentially they're being covered almost everywhere within the coast of the systems. Carbon storage and sequestration is, of course, one alternative. The degradation process for the seal walls and the behavior over many times millennia are difficult to predict. If the likelihood of leaks from its use reservoir is similar to the hydrocarbon reservoirs during the prediction, leaks 10 tons a day are expected to occur about in 10 to the minus 3 per reservoir per year. To expanded CO2, if properly emitted, may be very cold and hence remain close to the surface. Although not toxic, above a sub% of CO2, acts as a powerful brain dilatator. In 1986, the lake Nikos, a volcanic CO2 leak of 10 to the 5 tons, has killed all the people and animals within 15 kilometers from the place. The other important question, which I briefly touch, is the question of aerosol cooling, which is the main advantage of sulfur-related effect is that the height of the material can be captured is the order of millions of tons, not billions of tons, like in the case of CO2. But the problem is that the consequences on the climate will be catastrophic. Now, let me spend 5 more minutes of my time on a new method, which is natural gas without CO2. It's called methane cracking or methane decarburation. Is the spontaneous thermal dissociation of methane molecules in different sufficient temperature in the atomic component, which is CH4, goes to hydrogen and carbon. The hydrogen becomes the source of energy. The total absence of CO2 is the main reason for this new development. Cracking methanes with no CO2 emission uses no more energy than the standard reforming process, which, however, produces as much as 4 tons of CO2 for each ton of carbon. And here we can compare the two. Sorry, what's going on here? No, it's going the wrong way. Sorry, I beg your pardon. I have some difficulty in solving these problems. Sorry, excuse me. Where are we going now? Okay. What?
The bottom one?
It's going the wrong direction, sorry.
Push the top one.
Yes, I'm pushing the top.
Top or the bottom one?
I'm pushing the top. Okay, sorry, excuse me, it is something wrong here. I apologize for this. Where are we here? It moves like here, no rule. What's going on here? Jesus, what can I do? It's not working. It's not working. I don't know what to do. Can somebody help me? It's not working. I'm looking at this. What? Non lo so cosa fa, io seguo correttamente questo sistema. I'm sorry, I need a few minutes of help here because it doesn't work.
Where is the point?
the top one.
In the top,
Where is it going?
dove dobbiamo andare?
Andiamo avanti.
Qual è il punto? Io non so.
Avanti. Scusate. Can you push forward? Can you go to 29? Molten metals. Keep going. Okay, fine. Stop at this point. They gave me 2 minutes for this and I finish. If I can have the transparency. Okay, so the early, here is molten metals for methane decomposition, which you can see in this particular situation. You can see here that the natural gas is transformed by very tiny little bubbles into their components in a high temperature with molten metal, and then it separates itself into hydrogen and carbon, which are coming out from the system. Next transparency shows, next, shows can you give it all? Shows the photograph of our methane cracking facility, which we developed at KIT, and which is shown in the following 2 slides, showing the effect, the successful result. And my final conclusion then will be our recent successful experimental results at KIT, which is the following transparency. Next. There we are. In which the feasibility of methane TDM decomposition in a liquid metal bubble reactor has been demonstrated, and a single hydrogen pass yield 78% was obtained about 1,000 degrees. During the present experiment, no clogging issues were due to solid carbon were observed, and therefore it's a very successful experiment, which is the beginning of a creation of a new system in which we'll be able to do an industrialization of the process. The next transparency quickly shows the relative estimated cost that shows that indeed the new system of methane cracking is in fact producing events rate at a cost which is comparable to the one of the steam methane reforming calculated. Conclusions, therefore, notwithstanding the progress of renewable, the long-term energy production from fossils, can I see that conclusion, please? Is necessary. According to old saying, the end of the Stone Age did not occur because of the lack of stone. Likewise, in the end of the massive coal exploitation, there will be still a huge amount of coal left. Methane discarburation, TDM, in association with natural gas may become a valid alternative to renewable energies, since without CO2, natural gas has a capability of becoming a main, safe, and abundant primary energy source of adequate for centuries. Liquid methanol or derived products combining natural gas recovery of already spent CO2 could be made financially acceptable with a minimal footprint and without no costly new infrastructures. And let me conclude with the last transparency here, which shows the conclusions of the the last transparency here, which shows essentially a comment. Which planet will you leave to the future generations? In this summer, the lady of 15-year-old Swedish student went to strike, refusing to go to school until the Sweden general elections in September, to draw attention to the climate crisis. Thank you very much for this presentation.
Thank you.